Okay, so today we are going to be doing trigonometric functions. So our learning intention is to understand the knowledge, or to gain the knowledge of trigonometric functions and recognizing their associated graphs. We will be successful if we can recall the sine, cosine and tangent graphs, and if we can recall the cosecant, secant and cotangent graphs as well. We would be successful if we know what it means by the period and the amplitude and the phase of these graphs. So, to start with, all trigonometric functions have their graph that repeat at regular intervals. One full cycle, one full interval, is called a period, and these trigonometric functions are called periodic functions. So, for example, here we have the sine curve, and this is from, if we're doing it in degrees, that's from 0 to 360. Or from 0 to 2 pi. And this graph continues. So it mirrors, alright, it's got a range of -1 to 1. So it will continue on both sides of the y-axis. So the function keeps continuing, and it has a period of 2 pi, which means that every lots of 2 pi, the cycle continues. Okay, it's a quick sketch of it. Okay, now there's the graph of y equals cos x. It has a range of -1 and 1, and the same thing is it will continue every 2 pi, or every 360 degrees. Yep, just a quick sketch of how it would look. Yeah, same thing as it goes to the negative values. Yeah, there's one lot, and we keep repeating. Okay. Obviously, y equals tan of x. Same thing. So it has its range to infinity and infinity. It has asymptotes at pi on 2, or at 90 degrees, and at 3 pi on 270 in radians is 3 pi on 2. Okay. So it has a period of 180 degrees, or pi. Okay. Now, if we're going backwards, right, this would be negative pi, this would be -2 pi, -3 pi. Yeah, this would be negative pi on 2, -3 pi on 2, and so forth. Oh, I made the asymptotes in the wrong location, sorry. Because that's the continuation. Now, obviously, these are just sketches. They're not exact. If you use Desmos or GeoGebra, you can get the exact graphs. Okay, just sketches. All right, so the reciprocal of sine x is obviously cosec x, and like any reciprocal, it will reflect at its maximum or minimum. And so what happens is we have it repeating, such as it looks like this, and it will have asymptotes at the 0 values. Yeah. So if sine x was 0, it will have the reciprocal asymptote. Yeah. So that was 0, pi, 2 pi, 3 pi. And it will be asymptotes here. All right. So with the reciprocal of cos, we get a secant, and we'll get asymptotes again. It comes off its maximum minimum. Okay. And obviously with the cotangent, we still get cot Okay. And so those are the graphs, the reciprocal graphs of your trig ratios. Okay. So we state that y equals sine x has a period of 2 pi, so that every 2 pi it repeats itself. There's one cycle, there's an next cycle. That would be 4 pi. It has an amplitude of 1, so the maximum and minimum is 1 unit away from the center. Okay, and the center will be 0 at this stage. Yeah, so it's got an amplitude of 1. And the center is 0. Okay. Obviously, with its reciprocal, it has a period of 2, so it keeps repeating the same cycle, the same pattern, every 2 pi. But it has no amplitude. There is no maximum distance from the center. Cosec is the same, so we get a period of 2. We have an amplitude of 1 and a center of 0. Sec, we obviously have an amplitude of 2 pi. It repeats itself every 2 pi. It once again has no amplitude. And so with tan's obviously slightly different. I'll put this up here. Okay. Tan has a period of pi. So there's 1 pi. Or if we looked at it itself from 0 to pi, that repeats. Yeah. It has no amplitude because it goes to infinity and negative infinity, but it does have a center of 0. Okay. The cotangent, we have a period of pi once again. We have no amplitude once again, and we have a center of 0. Okay. So the amplitude of a function is the height from the center of the periodic function to the maximum or minimum values. So for example, once again, if there was a sine curve, center is 0. The height from the center to its maximum for the sine y equals sine x is obviously 1 from its maximum, or its minimum is still 1 unit, which is why it goes to negative 1. And the center is the average value. So if we add them all up, divide them by the total with the average value is 0, sorry, and that it will be the center. and it's equidistant from the maximum or minimum values. Yeah, that distance is 1, henceforth 1. Okay, let's do some examples. Just before we start with the example, we've got, so the period of amplitude of trigonometric functions in the general form, if we have y equals a constant multiplied by sine something x, well then it has an amplitude of the constant of k and a period of 2 pi over a, because sine and cosine have a period of 2 pi, but in tan we have a period of pi, so it'll be pi over a to figure out the to find the period. Obviously it has no amplitude. All right, so let's state the amplitude and period of this. Okay, so if we want to do the amplitude, and we'll do the period here. Okay, we've got sine of x. So the normal amplitude of sine is 1 and -1. Or sorry, goes from 1 to -1, so the amplitude will be 1. We're going to multiply it by 5. So the amplitude in this situation will be 5. The period would be 2 pi. Okay, I'm still saying amplitude and period. Okay, so we've got cos. So the amplitude of cos normally is 1. We're going to multiply it by its scalar of 2. So it becomes 2. The period is going to be 2 pi divided by a, and in this case a is going to be 4. So 2 divided by 4 would be pi on 2, which means that all of a sudden, if you had a normal cosine and it's repeating the period of 2 pi, it's now going to do this pattern every pi on 2, so it compresses it. That's going to be pi, so it's going to be slightly small. Yeah. That's just a very quick draft. All right, still with amplitude and period. So amplitude, okay, now it's a tan. So the amplitude, there's no amplitude of tan because it goes to positive infinity and negative infinity, so there's no amplitude. Yeah, because double infinity is just infinity itself. Yeah. The period of tan is normally pi, and now we're going to divide it by the a value, and in this case it's going to be 1/3. Well, that's the same as saying pi times 3/1, which is 3 pi. All right, we want to state the domain and the range of the following. Okay, so we'll do domain on the top and the range on the bottom. So the domain of sine x, well, that's a continuous function, so it goes from -infinity to infinity. Normally sine will go from -1 to 1, but because we've increased the amplitude by 5, it will go from -5 to 5. That would be the domain and range. Let's do it for this one. Okay. So cos normally goes from -infinity to infinity, so that range, the domain does not change. Even though the periods shrunk, it still continues. So it's still, the domain will still be -infinity to infinity. The range normally goes from -1 to 1. We've increased the amplitude by 2, so it should go from -2 to 2. All right, so we've got the next one, y equals 2 tan x over 3. So the domain of tan normally is -infinity to infinity. However, there are asymptotes, and we'll talk about those soon. The range goes from -infinity to infinity. So normally, if you think about the normal tan, so tan curve, it has an asymptote of pi on 2 and 3 pi on 2. Now, but we've changed the period in this example and made it that it repeats every pi on 3. So, that's pi. This is 2 pi. And 3 pi. So what it means is that it will repeat the period of 3 pi. So half of this will mean there's an asymptote. Yeah, because it's split in half. So an asymptote at 3 pi on 2, 5 pi on 2, 7 pi on 2, and continues on. Yeah, so any odd pi on 2, there will be an asymptote. Okay. Okay, so trigonometric functions can shift left or right. So the graph can shift left or right. And if that happens, then this is called a change in their phase. We'll do some examples. The phase shift of trigonometric function, you got y equals sine x plus b, or cos equals x plus b, or tan equals x plus b. They have a phase of b units. Now, if b is greater than 0, so it's positive, then it will shift the whole function to the left. If it is negative 0 or less than 0, it will shift it to the right. So here are some examples. We want to sketch the graph of f of x equals sine x plus 2 pi. What I'm just going to do first, I'm just going to quickly sketch now obviously I don't have graph paper, so it's going to quickly sketch the y equals sine x curve. Okay. I'll do it as big as possible. Okay, so it's 0, pi on 2, pi, 3 pi on 2, 2 pi. Okay. Now it says we're going to shift it positive pi on 2. So if the value is positive, it means I'm going to move it that way. I'm going to move it to the left. Yep, pi on 2 units. So if we think about it, this point will move 1 pi on 2 units to that side. This will go pi on units to this side. That would go to pi on units this side. And that one will go to pi on units here. And this one will move over here. So what we get this graph here. And obviously we can continue if we wish to. Yep. So it's going from negative pi on 2 all the way to 3 pi on 2. So it translated it pi pi on 2 units to the left. So now we want to sketch the function of cos of 2x plus pi on 2. So what I want to do is I want to actually note that my period has changed. So my period is no longer x is 2x, so that's going to be 2 pi on a, and then currently a is 2. So my period is pi. Alright, so firstly let us sketch the cos function first. Okay. So cos goes from 1 to -1. Just going to sketch it. Sorry. Alright. So a quick sketch underneath is that's y equals cos of x. Alright. Now, where this is pi on 2, this is pi, this is 3 pi on 2, this is 2 pi. Now we're saying that the period has shrunk to just pi, okay? So this whole thing is going to happen between here and here. So it will look something like that. Alright, I'm just going to, because I don't need that one anymore. Yeah, because that was y equals cos of x, so I don't need that anymore. Okay. So that currently, this one here is currently y equals, or f of x equals cos of 2x. Yeah. I'm now going to be shifting it, or translating it, pi on 2 to the left. Yeah, when it's positive, we go to the left. Okay, so just moving, I'll do it in green. This is moving to here, which means this is moving to here. This will move to here. I think that looks approximately 2 units. Yep. This is moving pi on 2. That's moving pi on 2. Okay, so then I have that the green function is the final one. So what I can do is I can now rub out anything I had in pencil. To give you the final graph. Okay. And that is y equals cos 2x translated, or pi on 2 to the left. Okay. So trigonometric functions can also shift or translate up and down. And when that happens, up or down, it's called a change in their center. So if sine of x plus c, or cos of x plus c, or tan of x plus c have a center of c, then if c is greater than 0, it will shift vertically up, and if c is negative, it will shift it down. Alright, it's quick sketches. So I'll do these quite small, so I'm going to, okay. Alright. Sorry. Okay, so normally cos, if that was 1 and this was negative 1, if cos was that, this translates it 2 units up the vertical, so 2 units up, so 1, 2. It would also be 1, 2, and 1, 2, 1, 2, 1, 2. So we'll get that as the final function. Alright. Here we have y equals sine of 2x minus 1. Okay. So we've got a couple of things happening. Minus 1, 1. Okay, here is our normal sine curve. Okay. Notice the first thing we're going to have to do is going to change the period. So the period now becomes 2 pi over 2, which is just pi. So I can rub out the sine curve, the original sine curve, and now it translates it down 1 unit. So if that was there, I go here, here, there, this one down here, and so basically what I'm getting so there's one period. There's the other period. And so that equals y equals sine of 2x minus 1. Obviously, we can continue on if we wish to. Okay. Okay, so we've got y equals 5 sine 2x plus pi minus 1. Okay. Alright, so we know the amplitude is going to go from 5, and so sine is usually 1 to 1. So amplitude is going to get from 5 to negative 5. But then I'm going to translate it down 1 unit. So what I'm going to have to do, if I do this sketch, I'm going to go from 5. Okay. Let's do that. Right. All right. Okay, so we've got the normal sine. So this is pi on 2 pi 2 pi. So normal sine curve. There, that's 1. Yep, minus 1. Okay, so that's your normal sine curve, rough sketch. We're changing the period. The period was the period is 2 pi over a, which is 2, which is, so that's pi again. Sorry. So rather than being 2 pi, it's now pi. Okay. It now shifts to the left by pi units. So this point moves over here. This point moves over here. This point moves over here. So, and this point moves here. That point moves there. So really, it's pretty much the same. Sorry. That point actually moves here. Alright, so what we do is we still get this happening. Alright. It has an amplitude of 5. So 1, 2, 3, 4, 5. So it stretches it all the way. But then I shift it down to 1. Yeah, so this will go 1, 2, 3, 4, 5. And I'm shifting it down to -6. So the lowest value will be here at -6. Yep. 1, 2, 3. Sorry. Center still says it's 0. No, center now goes here to -1 because I'm shifting it down. And so what I get what we get is this curve. something that looks like that. Okay. All right. Here's our last example. We want to sketch the interval of 0 to 2 pi, the graph of y equals cos of x plus 4 sine of 2x. So, if I have... Maybe we'll do it quite large. Okay, so that's 0, pi, 2 pi. Let's look at the first one. We've got y equals 2 cos x. So our normal cos x looks like that. But we've increased the amplitude by 2. So they're going from here to here. So notice that the key points, like your intercepts, the function stays kind of the same. The value might change, but the idea still stays the same. Okay, so that's y equals 2 cos x. Let's look at sine of 2x. So we've met this sine of 2x that happens every pi. But now we're increasing the amplitude to 4. So we've got... Maybe I'll do that in a different color. Now what we want to do is we actually want to add this red curve with the pencil curve. So we notice that looking at these points, so at pi on 2 and at 3 pi on 2, they're the same point. Okay, and that's really important. So we know that negative 4, 3, 2, 1, 0. I moved it slightly up. Okay, what I'll do, just so that we have it on the same dimension, same plane. All right. Minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4. Okay, so we know that that's going to stay the same, and this is going to stay the same, because 0 plus 0 divided by 2 is still 0, okay? Alright, looking at this point at 0, we've got 2 and 0. Well, 2 plus 0 is going to just stay at 2. So we got another one here at pi. So this is pi on 2, pi, 3 pi on 2, 2 pi, because that's what we need to be drawing the graph for. So we've got pi and negative pi on 2. If we add that, that's going to be negative pi, negative 2, I mean. Okay, it still comes at 0. So we've got 0 and 2, so add that together, it stays at 2. Okay. And we can kind of start to see that we have some kind of curve. What we can do is, if we want to be more exact, we're going to find our points, and we can find what these values are at 2 cos x, so we can create a table, and then we can add, and then also find what 4 sine of 2x is, and then we can add the values together. So at 0 we get 2. At pi on 4, which is halfway here, right? Yeah, pi on 4. We get 4 plus 2 pi. If we're using a calculator, 4 plus the square root of 2, is 5.4. So it'll be over here somewhere. So we're going to go up, which is adding that plus whatever that is. Yep. We're going to come back down to 0. Now we're going to go down to negative 4 minus 2, which is basically that plus that extra bit. We're going to come back to negative 2. Yeah. So then we've got 5 pi on 4. Which is negative 2 over square root 2 plus so we get just want to double check that value. So I've got 2 lots of cos 5 pi on 4 plus 4 sine 2 lots of 5 pi on 4. Yep. Yeah, so we've got 3 pi on 2 is 0. 2 pi is 2. This is positive, and this one will be negative. So just that value, negative square root 2. Sorry. Yep, negative square root 2 minus 4 is minus 5. No, sorry. 2 square root 2 minus 4 is minus 2.5. So somewhere here. Yeah. So it would look like that as a rough sketch. Okay. And then that would repeat as well. Okay. And so that is the end. That's the end. So just to remember, recap. All trig functions are periods. The amplitude is the height, or the average distance from the center. The phase is if it moves left or right, or up and down. We've got center, amplitude, phase. Yep, period, amplitude. All right, thank you very much. Bye.